Hi guys, so Christmas is nearly upon us, yeah, and I went to the car boot sale at the weekend and the sign's worn out. I need to print a new one, yeah, just imagine it there, Word Electronics Repair Car Booty, yeah. But I'll make it as a new one. Anyway, so there was quite a few computers down there. There were three relatively oldish ones, but not oldish enough, if you know what I mean. So they were PCIe, like an AM3 machine, I think there was, and possibly a 775 and something else. And I didn't bother. There was a couple others that were kind of like Dell or Acer, and I didn't bother. So I got two machines anyway. So I'll probably be down there again this weekend, Sunday, Boxing Day in the UK. I don't know what they call it elsewhere. It's not a public holiday here. We have one on January the 6th, which you guys don't have, yeah, unless you're in Spain. So I might be down there this weekend. In fact, I'm sure I will be down there this weekend. Possibly nursing a hangover from Christmas Eve. We're going out for the night, but who knows? Sorry, from Christmas Day, sorry, we're going out for the night. We go out for Christmas Eve as well. Might as well enjoy it while it's here, yeah. So anyway, I got a couple of machines. This one, I paid the guy €20. We'll make a video of these because say after the weekend, after Boxing Day, I might have some more. Depends what's down there. I might have a look at those old ones. If I can get them cheap, like 10 or 15 euros each, I might buy them. Because we like gaming motherboards, but quite old ones, yeah. So this is H81M. Gigabyte S2 PV, second generation I something, unless there's no CPU or anything, in which case it's a second generation I nothing, yeah. Hiding to nothing, I've had them before now. But €20, it's got a couple of sticks of RAM in it, which look like Corsair XMS, but they'll be DDR3, so it was cheap, yeah. Is this a gigabit? Oh, it is. I might need one. I've got a bit of a problem with one of my computers, the onboard. No, it's no use. That's PCIe only. Okay, that wasn't so good. So yeah, let's check for shorts on the 12 volts. Let's plug it in if there ain't any. Let's see what we got. There's no hard drive in this one, but never mind. I didn't show you guys. I'm going to tell you. There's the machine I had a couple of weeks ago, Paco said on it, it did boot into Windows. It's the first time I've ever found one with porn on it. Yeah, it's the first time I've found one. I formatted the hard drive, by the way. I'm not going to tell you what happened to the filth. But, you know, waste not, want not, as they say, yeah. So, yeah, there's no short on that. There's no short on that. I was speaking to a friend actually does a lot of software upgrades and jobs, and he says he's quite regularly had them with smut on them, you know. Yeah. So, enough waffling. It's Christmas soon. It's Christmas. Yeah. 2 more sleeps, as they say. Of course, you'll be watching this in summer, and that'll be completely irrelevant, but I don't care. So, no shorts on it. Put some power on, let's switch it on. Nothing went bang, that was good. Oh, little lights come on the front, I mean. Like this like, little thing here. Oh, hang on, something rattling in here. Didn't like the sound of that. I've unplugged it here. Well, whatever it is, it's gone to the front of the machine. Whatever's rattling around is now on the front of the machine, where it can not do so much harm, yeah? Okay. So yeah, well, I won't show you the little red light on for something rattling in front of the machine. Yeah. What happens? Press the button. Noisy fans. Oh! Even noisier when they speed up. And it goes beep. Like if I plug the monitor into it, I might even get a picture. Hey, let's see what we got here. What have we got here? Well, monitor's plugged into it. Let's move the camera around. Let's get ready for the main event. If anything happens. Okay, that'll do. Power's on, power's back on. No, I switched something off, oh yeah, that one. Power's on. Good bit of noise. Whee, better noise. And it goes bleak. Come on, give us a picture. Give us a picture. HDMI, no, let's go to DVI. Nah, it wasn't good. Oh, oh yes. Hey, CMOS check some area. Okay. This one's booting into the BIOS. So let's get the motherboard out. Let's stick a hard drive on it. So let's see if it'll boot into Windows 10. Yeah. This could be a bit of a bonus. So let's see what we've got when we do that. Okay, I've got the motherboard out. This is the case actually. I'll probably keep this one. I mean, normally I have the motherboards and processors and what I can sell on eBay, and I sling the cases. But this is quite tidy. Vento AH chassis. It's quite reasonably solidly built. I mean, you know, it's not an amazing gaming cabinet, but it's good enough to be useful, I think. It's a shame this came without the hard drives, because these are all tied up. It's obviously had 2 hard drives, and the other one was going to the optical drive, so it probably has some decent hard drives, you know, capacity wise. But anyway, that I think I will. That one is worth keeping. So I have a lockup by the garage as well. So I keep stuff like that in there. Yeah, it's getting a bit full, but those sort of things sometimes I think they're too good, a bit too good to throw away. Yeah. So anyway, what we got here, we got a couple of sticks of Corsair 2 GB, 1333 megahertz, couple of them. So I think we'll put our power supply on, although I'm sure the other one's good. And we'll power this up with a hard drive which has a known good Windows 10. And let's see if it actually boots. Okay, so I've connected our known good power supply and a hard drive with a known good installation of Windows 10. I'll just move the camera so you can see the monitor. Say hi to instrument cam, yeah, hi instrument cam. This is what you normally see me on, and the meter and various things, yeah. So switch it on, let's see what it does. Yep, oh, rather nice, rather attractive BIOS screen. I'm not sure about that though, because it's loading. No, it says it's loading. Definitely loading the BIOS. And so definitely loading Windows. Give it a few seconds. I'll just pause the video, save you guys waiting. Yeah, there we go. So we're up into Windows now, loading hours. So yeah, let's just wait till this loads up, and then let's have a look to see what we've got on this. I mean, it could be a Celeron, it could be a Pentium Gold, it could be an i, anything really, apart from an i nothing. It's definitely not an i nothing, or an ID into nothing. It's not one of them. This is the same guy, by the way, who last week sold me 2 faulty computers. One was a i5-4440 that had 1.7 volts on the Vcore for some reason, smoke coming off the 12 volt connector, which I don't know if the CPU is any good or not, but we're going to find out shortly. And he also sold me the i56100, was it something like that? It was, let's see, I've got here actually, what is it? It sold me i56400 that we can't test the CPU because the motherboard doesn't work. So it goes to show really these guys, they really don't know what they're selling you. So when he says it's good or when he says it's not good, actually this guy never says, it's the other guy that says it's good, and that means the light comes on. If you're lucky. No, sometimes they do work, sometimes they don't work at all. Yeah. Okay, so this is just specky. Let's have a look to see what we've actually got in this machine. Which CPU is actually fitted in. It's one moment. My hard drive's not the fastest of things, by the way. Okay, so let's have a look. CPU analysing, what is it? Oh yeah, it's a G840 Pentium Gold. Nothing overly exciting really. All the temperatures looking good though. Okay, so not a very exciting CPU, but for €20, and considering I'll probably find use for that case at some point, whether it's quite a nice cabinet, that's all right, and it works. Yeah, it works. The scene, yeah, there's just 4 gig of dual channel RAM. That's another reason why it's taking a while to load Windows 10. It's got two 2 gig strips in. Okay, that one's looking good. Let's have a look at the other one. Okay, this is the other one. Again, it's quite a nice case, this. I think I'll probably keep this. It's in pretty good nick. It's got on it here, which is for me, a Windows 7 license, which are always very handy to have, so I'll keep that. Actually, you know, it's interesting from the legality of that. If I bought the computer and I assume the hard drive is being destroyed because it has personal data on, does that mean then I actually own the Windows license? Because I have the license. Yeah, does that mean it's mine? Yeah, not as I'm overly worried like about it, but just thought I'd ask, see what people thought. Okay, 600 watt power supply, quite alright. H81M-VG4, yeah, H81M-VG4, Asrock. These motherboards have problems. They are known to have problems, yeah, not starting up. So, let's have a look. Let's have a look. Let's go on to resistance once again. Let's look for shorts. This is from the guy who says it's working. It usually means the lights come on, yeah. Sometimes worse than that. And sometimes they are working. But the actual case with this one, he didn't actually say. This is the guy who had the 3 older machines and I decided I just wanted one this week. €35. I paid a bit more for this. It's a more slightly newer machine, but I know the motherboard, if it's working, is worth a bit more than that. Whether I'm pretty sure there's a CPU under there. It's going to depend on the CPU again. This one, if there's going to be a profit in that, I think. The case and the power supply are quite nice. Could be worth €10, aren't they? Really, for some, you know, I'll find somebody to stick in here. Okay. So anyway, there's no shorts on this one. So let's have another look. Let's see what condition this one's in. Okay. Give it some power. Switch it on, see what happens. It didn't go bang. Oh. I think, yeah, I think the blue light on the front kind of flashed on and went off. Yeah, see? And I think the fan just spun a little bit and went off. There's no RAM in it, fair enough. Could be a power supply problem. Is the power supply actually going off? Let's have a look to see what it's doing. Let's go to voltage range. So let's go and just see if we've got standby, which I'm hoping we have got standby. Switch it on. So we've got standby. Go over to the 12 volts up here. That's as good a place as any. Let's switch it on and see what actually happens. Power supply comes on and goes off again, basically. Okay. I'll take the motherboard out, and we need to try this on our known good one. Let's see what it's doing, yeah? Okay, giving me to automate, and I'll take it out of the case. Okay, so I've got the motherboard out. Let's have a look at this one. So, just checking for... I mean, we know there was no shorts on the 12 volts. Yeah, just go to resistance range. Okay. Go to the 12 volts. There's actually a bit of charge in the capacitor still, that's why it's reading like a minus voltage. Yeah. But there's definitely no short there, that's for sure. This is the side that does go to ground. Let's have a look on the Vcore, 30 odd ohms. First of all, tells me this is probably something like an it's like a Celeron, I think. The reason we had some 4th generation, and I was playing with them last week. We saw the video. I was playing around. I was just looking at various resistances. and I think I5 was reading about 22, and the i3 was about 25. So this is reading higher on that's a CPU core base I'm reading on Vcore. That suggests this is probably something like a Celeron, but could be wrong. Yeah, this is supposition, guys. Yeah. But let's see. This is the RAM phase. No shorts here. And that's reading well. Let's just have a look on the other side. I mean, one side the FET will go to ground anyway, so let's have a quick look. Check on the coil. Yeah. That's no shorts there on the RAM phase. Could be shorts around the PCH. I don't know. I mean, I don't see anything obvious with this. Yeah. Let's get the power supply. Let's just check on the 3 and 5 volts as well, see if there's any shorts at all. Otherwise, it could be a faulty power supply. So let's have a look. So 3.3 volts. No, there's no shorts. That's a normal sort of resistance. 12 volts. That's plenty. 5 volts is looking good. Yeah, it's usually quite high. So there's no shorts on this. So at the moment I'm working on the basis we might have a faulty power supply. So we'll get the 4-way connector. I'll just find it on the end of my cables. Too many cables. Where's it gone? I'll find it. Look, it appeared by magic. Yeah, magic happens here. Magic happens here every week. Okay, so yeah, I'm working on the fact we might have a faulty power supply, but there again, because this is an Asrock of this type of generation, all bets are off. Yeah, all bets are off. Okay, let's power on. Let's find the switch. Here we go. Well, that should be something stupid like a stuck-in reset switch or something. Panel. Oh, that's what it does. Okay. Stay on for a bit longer, didn't it? Let's have a look. Voltages. CMOS. Dead. Let's change that. Just get another one. Okay, well I've put a new CMOS in, so starts and stops again. Doesn't bleep. But if I hit the start button again, it starts again. So it's not tripping the power supply out, otherwise it wouldn't come back on. That's this power supply. I happen to know that's how this one behaves. Yeah, it trips off and stays off. Let's have a quick look to see if Vcore's coming up, yeah. Just try and get a connection on here. There we go, onto the MOSFETs. I told you I now need 3 hands. Yeah, I've got it, I think. Okay. No, it looks like Vcore is not coming up. But we know that, I'm sure we measured this, the 12 volts is coming up. Yeah, so Vcore is not coming up on this board. That's the first thing we can say, I think. But there's no short on Vcore, yeah. So this has some sort of problem. So have a look now to see which CPU's on this. Because the resistance I was reading. If there is a CPU in it. Let's have a look. What's he sold me? Oh, he sold me for too much money, eh? Right. We have a CPU. So my theory on the 4th generation with the resistance of 30 something is this is like a Celeron or a Pentium Gold. Just based on something I did last week for the first time ever. Yeah, not only based on years of experience. I'll tell you what, let's zoom the camera down and we have a look together. Okay, so let's look. Let's see if my theory is correct, yeah, based on the resistance of the CPU. Haha. Guess what? Can you see it? Celeron. Celeron. I'm starting to be able to tell the processes from the body resistance now without taking the top off. I've started taking my meter out with me again and just checking when I don't know, see what the resistance is on Vcore. And if I know the generation, I think I can sort of work out what they are. Yeah, okay. So, I took a chance, you know, I'm buying this stuff. I take a chance to see what the generation is. Well, the good thing is with this motherboard actually supports our i5-4440, which we don't know if it's any good or not. So what we can do, well, that was good. I mean, probably this motherboard's faulty and the CPU is fine, yeah, I'd imagine. But let's just stick our i5-4440 in this motherboard. And let's see if that does anything by any chance, yeah. Let's give it a go. So, because it looks like I don't have Vcore, I won't bother putting heatsink on it, but what I will do is get the meter where you can see it. One moment. Yeah, there you go. So you can see the voltage meter now. So once again, let's go on to single-handed onto Vcore. Well, let's see if it comes up with this CPU. I mean, I don't think it will. I don't think it'll do anything different. Let's just switch it on. That'd be a good start. No, does the same thing, kind of starts and stops again, and no Vcore. Okay, well, I mean, first of all, the PCH is not getting hot and standby. That's a good sign, yeah, that's a good sign. Let's look at the current this PCH is drawing. Let's get the microamps meter. There we go. Let's have a look to see what current we have. Microamps, yeah. Light it up, yeah. Let's have a look. So, positive to the CMOS battery, negative to push the little clip back. Yeah, 2.39. So that looks good. I'm not saying the PCH is good, guys, but I'm saying that the real-time clock is running, and that means chances are, at least to some extent, the PCH is good. Yeah. If I was reading a high current, I could say it's no good. Yeah. So that's that. You don't suppose for 1 minute this might not start without any ramming, do you? I mean, that'd be rather strange, but let's take a bit of ramming and let's just try it. Actually, I'm changing my mind about that. I can't see how it could not start. I mean, I don't get any Vcore. How can it possibly test that there's any ramming if there's no Vcore? Yeah. So, the other thing that occurs to me is possibly a problem with the BIOS, and because the BIOS on this just happens to be in a socket, which makes it very easy to program. Let's program the BIOS and let's see, you know, if that does it. Okay, well, I programmed the BIOS, and while I was doing it, I mean, it was just a plug-in chip, so it was easy, but while I was doing it, I thought to myself, daft bugger, how can it possibly be a corrupted BIOS when you haven't got any Vcore? So, if there's no Vcore, how can the CPU actually use any instructions from the BIOS? Yeah, it doesn't make sense, does it? So, it's Christmas, that's my excuse, it's Christmas, yeah. So, I don't for one moment believe it's going to make the slightest bit of difference. But let's put the power on and let's just try it. So, it switches on and switches off. That's exactly what you expect it to do, because there's no Vcore. Yeah. Oh well. It didn't do any harm because I put the latest BIOS in it, and it was only a plug-in chip, so it was not a bother. So, okay, what we need to do now is have a look really to see if we can figure out why we got no Vcore. If we start from there, look at the VRM for the Vcore. Is there a fault in it? Has it got power? Has it got enable? We can use the data sheet, and we can also have a look to see if we've got a schematic for this one. 1 minute, let's see if we've actually got a schematic or a board view, because that would help a lot. And in actual fact, yes, it looks like we have got a board view for this one. There's several. I mean, all these board views, by the way, are on the Learn Electronics Repair Discord. Yeah, I've put them all on there for free. So anybody who's looking for some schematics, go on there and have a look. We've got a lot of GPUs, a lot of motherboards, and some of the other members have uploaded some laptop and Apple as well. So there's plenty on there, yeah. And if you've got schematics, please come and add to them. But anyway, ours is a revision 2.01. And there seem to be a few different here, maybe slightly different, but we can have a look. Yeah, so this is the board view. So yeah, we've got a board view. So that means we can actually have a good look around this one and see where the problem is. Okay, so let's get on with that then. But we actually have some more information for this motherboard as well, which will also help us in repairing or at least diagnosing the fault on this if in the end we can't actually repair it, you know, due to lack of parts or something. So what I have here also is this. This is gigabyte, whereas ours is an Asrock. But this is the H81M-VG4 power on sequence, and it has the same chipset as our Asrock board. So a lot of the information on here is going to be valid to ours. And this shows us the sequence of events basically that happen before the motherboard boots up. Okay, and we know ours is switching on, but it's not starting the VRM for some reason, then it's switching back off again. So basically the way to follow this chart, I'll just show you through it, is start from number 1. Yeah, okay. So the first thing we have is 5 volt standby from the power supply, the ATX power supply, yeah, and that goes through a couple of FETs and generates a 3 volt rail here, yeah, and it also goes through another FET and develops another 3 volt rail. But the difference between 3 volt dual and 3 volt dual PCH, I honestly don't know. I assume I mean, it shows you both go into this H81. This is your PCH, yeah. It's showing it's going to here. But anyway, it generates these voltages, and it also gives a signal this DPR power OK. So all this effectively comes into this chip here. So this is like steps 3 and 4, yeah. So once the PCH has, well, the place must be on fire. Can you hear that? I don't see any smoke and flames. Okay, so once the PCH has this 3 volts power and this signal as power OK, it sends a couple signals 5 and 6. We're just following the sequence 5 and 6. These are the sleep state signals, and it's sending them to this chip. Now this is the Super IO, the SIO chip, yeah, which may or may not be the same chip on our board, but it will work the same way because we have the same chipset. So these 2 sleep states go to this chip, yeah, and also coming on here, number 7, is the power button. Okay, so when we press the power button, it starts, yeah. So we now need to find where's number 8. I know it's here somewhere. One moment. 7. I move the camera around. I have it balanced on top of the screen actually. Yeah, okay. Power button. So you press the power button, which effectively grounds one of the pins on the Super IO, which then sends the signal number 8. Power button, whatever, switch, yeah, power button switch. So back to the PCH, and it now says we press the power button, okay? So now the next thing that happens is going to be number 9, yeah? It sends the PS on signal to the ATX. This is the green wire going to the ATX, so it effectively grounds this wire, yeah? The ATX then switches on, okay, number 10. When the ATX powers up, this is V in. I'm guessing this is probably the 12 volts, but obviously you got your 3.3, your 5, your 12 volt going through the power supply, yeah? And it generates a signal here. Now, this is coming from the Super IO signal, and also these powers, I'm guessing, through these resistors. So this may well be on 2 different pins. This chip is going to be the pulse width modulator control for the VRM, for the Vcore VRM, yeah? Turns that on, and this switches on the Vcore. So your Vcore now comes up, yeah? And it generates a signal here, VR ready, VRM ready, basically, back to the Super IO. And then a number of other things happen, yeah? But that's as far as we need to go right now, because we know some things, yeah? We know full well that when we press the power button, yeah, step 7, it sends a signal back, and we can assume it sends this signal up here, we don't know, but it certainly sends a signal to here because this switches on, yeah? When this switches on, we must have power to here, but we don't have Vcore. So where it's going wrong is somewhere effectively on the step 11, or maybe this step 8 back to here. That is where it's going wrong. We don't get the step. I'm assuming we'll have to find. I'm assuming we get the signal to turn the Vcore on. Yeah, we don't get the VR ready. I suspect we're not getting the signal to turn it on. So once again, as I said to start off, this is really where we need to start. But we do know somewhere between, effectively, we even know where the step is. Either step 8 isn't working, maybe something here. Well, I'm not sure this PCH actually then is involved with switching this on. It looks like it's coming from here. So it does look like the problem is somewhere between the communication between here and here after you switch the switch. Yeah. Okay, so let's have a look next. This is a gigabyte board. So let's have a look to see if this is the same chip. If not, I mean, it's going to work in a similar way. And we have to look at the enable and the power onto the the VRM, which is kind of where I said we were going to start to start with in the first place before we found this. Yeah. Okay, so let's go back over to the board view and let's have a look. But before that, let's just check on our board to see what chip we actually have. So this is the VRM chip, and the first thing I noticed is what we have actually is a bit of a mess around here, like it's dusty or let's get the microscope. Okay, so the first thing I notice is it's a bit messy. There's something on this, I think it's not easily coming off it. And generally down the sides a little bit messy, to be quite honest. It's mainly up to here though, so it's mainly here. So I think the first thing I'm going to do is try and clean this off, and I might just stick it in the sink actually. Let's have a look to see if we can tell which chip we actually have on our board. Okay, well, I don't think it's the same chip. It's not the same chip. It's not that ISL, it's something else. But it's doing the same job. But straight away you can see the whole area is nasty. Yeah, it's horrible. So there's obviously been something got on here, liquid by the looks of it, and made quite a mess, just especially just here. Yeah, so I think the first thing, yeah, just this area particularly, and it doesn't look very nice around the chip. So the first thing I'm going to do with this is I'm actually going to put it in the sink with soap and water, give it a good clean, let it all dry out overnight, and then next day I'll come and have a look to see how it looks once it's cleaned up, and then we can proceed as we were going to do. So we can, if that doesn't automatically fix it, which it might do, then we can proceed as we were going to do. So we can have a look to see if this chip has power, if it has an enable, yeah, and we can work it from there. And we've got a lot of information to go on, so I'm quite confident we can at least diagnose this, and with a bit of luck we might fix it. I've given it a good dry out then, so it went into the sink with some hand wash and water basically, and then a good rinse, and stood a fan like a PC case fan in front of it for a while, just blowing air onto it. And then I left it overnight, a couple of nights actually, because it's been Christmas in between. So, in fact, no, it's had 3 nights, yeah. Anyway, so, come back in this morning. I was just checking around the socket. I mean, this looks okay. I had no reason to suspect it wasn't. So, this is the area of the circuit which I've cleaned. It's still maybe slightly a little bit messy, but it's much better than it was. Yeah, it's looking pretty good. I mean, I can see a bit of corrosion here and there. You can see, I'm sure you can see it yourself, but the worst of it's gone now, and I think we can give this a try. Let's see what it does. I mean, it might just power up now, to be quite honest. If not, then we'll be looking at this chip. We'll find out what it is, get the data sheet, we've got the schematic, and then let's have a look at the enable signal and the VCC, the power to the chip, and let's see what's happening, see if we can work out where the problem is. Okay, so let's get it powered up and let's see if it actually boots up now. You see, it's funny that, isn't it? I've just noticed the overhead camera, and now I can see some problem in the socket. Whereas with the microscope I couldn't really see anything there, so we need to have another quick look at that just to see what's actually there. Yeah, is it just something that's maybe just got in there while I was cleaning it basically? Alright, let's have a look at that. Okay, it's there. It looks like something's got in. I'll just use a microscope and just see if I can just get this out of here, whatever it is. Oh yeah, it's just a bit of something that's... I think if I just turn this upside down, effectively, it'll probably come out anyway. No, it's still in there. It's kind of like I can move it. It's kind of underneath that pin there, yeah. Can you see? Yeah, it's in shot. Come out, whatever you are. Okay, now it's gone. And I don't see any. Don't see any other real problems in here now. Yeah, that's looking better. Okay, let's power this up and let's see what it does. Okay, I fitted the CMOS battery back on. Just while we're at it, just checking out the shorts, just to be sure. I mean, nothing I've done should have caused a short, but you know, it's just worth a quick check on. Yeah, that's the CPU resistance. That's fine. Okay, so let's find the other power for this. And let's see if it actually wants to do anything a bit more useful now. Yeah. Huh. Okay, so there we go. Oops, one more, guys, and we're ready to go. Power into the power supply is a good one. Yeah, okay, we've got power on. Okay, so let's see what the board does now. Well, it started, and it stopped again, so it didn't make any difference, yeah? It just came on and went off again, and let's have a quick look to see if we have anything on Vcore when it comes on. So, just find somewhere to stick the ground lead. Positive onto Vcore, there we go. Yep, you can see the meter, yeah, it's on volts. Let's have a quick look now, see, okay, 1 and 3, just hold of the switch. Okay, nothing. So we still have no Vcore. Okay, so let's have a look now at the schematic. Let's see what we can see around that chip and see what's going on or not going on, as is the case most likely. Okay. Okay, so we've got the meter on the resistance range there, so you can see it. And I've got the closest I think I can find to the actual board view. I don't seem to have exactly this revision, but I'm sure this is going to be very, very close to the one that we have. So the first thing we need to do is to get this effectively the same way up that our board is. So just view, flip vertically, wrong way. The vertical and horizontal don't seem to be quite what you think it is. Like I said, flip horizontally, for me that's gone vertical, but anyway, I suppose it's just the way you call it. Okay, so that's kind of like the same way round as ours is. And we can see here, this is the chip itself. Pulse width modulator controller. We've got the part number RT8889, yeah, AG whatever QW Richter. Okay. So that's the actual chip itself. And we can see which is raised, so pin 1 is here. So I could look up the data sheet for this, but let me see if I can just get from the layout here. So the things I'm looking for is any enables, yeah. So there's Vcore enablers on pin 3. Okay. Voltage ref is always worth having a look on the 11, because if the voltage reference isn't correct according to the data sheet, we'd have to look at the data sheet to see what the reference should be. Then we can pretty well say the chip is faulty. We have a few things down here. VR ready, this will be the output to say, you know, effectively it's running. So 34 VCC, this appears to be the power PVCC. So let's have a look on ours. So 34, you can see as I click in the thing here, it's the same as clicking in here. So for instance, if I click on 3 here, it clicks here, or I can actually click on the pin number itself and it clicks there. You know, they kind of like, the two are basically the same thing, yeah? So it depends how you prefer to use this. But we can see easily that there's a capacitor here, horizontally, which our board may not be fitted. And there's 2 here, so we can measure the power getting to this chip here. Yeah, that's a good place to check. The other thing we're interested in particularly is the enable on pin 3. And we can see again that actually goes down to, well, there's a transistor down here actually. I can see that on the board, so that's a good point to measure that, yeah. And obviously, this will be the gate. You can see I'm hovering the mouse over. In fact, I'll click on the device, it'll show us here, we see. Vcore enable, the signal OTP enable, which I'm guessing is a signal coming in, and when you switch this on, this OTP enable passes through here to the chip. I'm pretty sure that's how it would work. And this is the gate that switches it on. But for now, we're interested just if we've got an enable. We can have a look later to see why if we don't have one. Okay, so we can look down there, and the other one back onto this chip was the VCC, which I'm sure was actually here. Yeah, show me there, VCC. Okay, so let's power those up. The third thing we'll look for as well while we're at it, well, I'm sure it's there, I can measure the resistance. These are your high side MOSFETs, okay, and this will be the 12 volts coming in. So we're showing here 12 volts, yeah. So I'm interested, has the VRM got 12 volts power coming in because it needs that? Has the chip itself got power because it needs that? And is it enabled? Okay, let's go back to our board and let's have a look to see what we've got. Okay, so first thing, guys, we'll just check to see if the points at which we want to measure actually go into the chip. So these two capacitors here, yeah, and this here, this is the power coming in, the VCC, and that should go to the chip here. That's the fourth pin in, yeah, so that is getting to there. The other one we want to have a look is the end of this transistor here, yeah, and this is the enable signal. So I'll just keep the meter on that. We'll just move the thing into view, yeah. So the enable goes down here, it's about the third or fourth one down. Yeah. Okay, so we know that those points, you know, those tracks are actually good. So we know that whatever we're measuring, you know, on here and on these capacitors is actually getting to our chip, yeah. So we'll power this up and let's have a look to see. In fact, no, just before we power it up, let's just check something. So I'm on ohms range. I'm just looking for shorts on these pins. So I'll go to ground and I'll go to the enable down on this transistor. What have we got? Well, we got 9k. We've got quite high reading there. That's okay. What have we got on the power pin coming here? So ground again. So it's any of these capacitors here. What's that reading? Well, that's low. It's about 6 ohms. Okay, it's not short. I've just touched the leads together, but it's low. There's a low resistance here. To me, unusually low. Yeah, we can have it to see where that comes from. Well, let's just check first if we've actually got any voltage on there. Okay. Otherwise, there may be a problem with this chip. I mean, I'd have to have a look at the board view and see what else is connected to that point. But I'm a bit surprised at how low that is actually reading. Okay, so we'll turn the power on. We'll power it up. But the thing is, it only stays on for a second, and that's the problem. If I give me 1 minute, I'm just going to clip my black meter lead to the ground, so I've got one hand free, yeah? Okay, so I've just taken a crocodile clip lead, basically. It fell off, I'm just going to show you, yeah? So I've just clipped the meter, you know, onto ground, yeah? That's the point. So I've now got an actual hand free to actually do this, switch it on and measure at the same time. So again, we can see from here we have this quite a low resistance to ground. So we can measure it there. We know this is going to be powered to the chip, or it should be. I can now switch it, put it onto voltage range and switch it on. And let's have a look to see what we actually get. And we don't get any power, yeah. There's no power getting to the chip itself, so we need to see where that's coming from. I'm not sure you can see where I am on here. Yeah, can you see it now? I'm on there. Yeah, I'm on one of these capacitors. We know this is the power coming in. So this is missing, yeah. This is missing. There's no again. There's no power actually getting to the chip. The van goes and it goes off again. While we're at it, let's just check the enable. It doesn't matter because at the moment we know there's no power, but just out of interest, this is the enable pin. Let's see if it has an enable as well. Yes, it does. Did you see that? I can set the meter to hold, actually hold on the highest reading. If you just give me one moment, I'll just do it. That's on hold now. Okay. Ground clip fell off, just to be awkward. On here, okay. So we're on hold now. So this will actually just show you the highest voltage. This is the enable. This is a very useful facility if you're on your multimeter. Look for this, if you're buying a meter. Yeah, so 1.07, that's fine. I mean, to me, that's high. That's enough for an enable signal, yeah? Okay, so the question is now is why does this chip not have any power here, okay? So we need to go back to the board view. Let's have a look to see where that actually comes from. So this is our board view, yeah? And this is where I was measuring on these capacitors, which we can see goes here, which is PVCC. I suppose I should just check that is the power pin. I'm sure power VCC is exactly what it is, but just to be 100%, let's just get the, if we can find a data sheet for this chip, let's just have a quick look at it and let's just be sure. Okay, I found the data sheet, and it's good that I did actually, because if you look here on this pin, PVCC, okay, it's saying driver power, connect this pin to ground by a minimum ceramic capacitor, that's supposed to mean, yeah. But anyway, it's just saying connect it to ground via a capacitor, which suggests that this is actually generated by the chip itself, yeah. And if we have a look on, here's the functional block diagram, we can see here PVCC, UVLO, I'll come to that, VCC. So VCC is the power in, and that is actually on a different pin. Let's have it where was VCC. Well, there's the enable, that was pin 3. So somewhere on here, VCC, pin 18, okay. So pin 18 is the power supply, not the one I thought it was. Connects pin to a 5 volt power supply, okay. So it should be 5 volts on there, yeah. So VCC comes in here 5 volt, and this is what is it? It's a voltage regulator. I don't remember what it stands for, yeah. But it's a voltage regulator internally, and this is feeding this voltage back out again. So first of all, we need to see if we've got any VCC, yeah. And if we have, and we haven't got this one, and this is where we're needing quite a low resistance, I'm wondering if we've got a problem with this chip, or there's something on this rail which is maybe through a resistor is short somewhere. Okay, so let's go find VCC instead. So VCC is on pin 18, yeah? Now let's refer back to our board view. Let me just check to go big, there we go. So this is our board view. So it's actually pin 18 that we're interested in. Let's just get a thing up here. Pin 18, oh, it does say it's VCC there, yeah? It does say VCC, I just missed it earlier, yeah, so pin 18. So we can see now, pin 18 is here, and it's attached to a number of components where we can have a look to see if we've got the voltage, yeah. So I'll do the same thing, we'll find one of these points, we'll do a resistance check to here to make sure the track's okay, and if it is, we'll measure the voltage here. Okay, so let's go back over to our board and let's have a look at that and see, see what we've got, yeah. So from the board view, we can see that this resistor here, in this end of this capacitor, this is on VCC. And if I just angle it, you might just see this is a 2.2 ohm resistor, okay. And this end should be connected to our chip, and it is, yeah, so we know that there. So this is where we can measure the VCC. While we're just at it, just check the resistor as well. Yeah, 2.3, I mean that's reading basically correct. So we can check the voltage now here to see if this chip has any power. Okay, I'll just get my meter ready again, click the ground lead on. So I'm on volts again now, I've got the ground lead attached. This is the end of the resistor, so let's have a see what we get here. Oh, something not switching off. I'll probably switch something off somewhere. One moment. Switch the ATX power supply on, Richard. Okay, so let's just go again. So let's get onto this resistor here. Okay, this is where we want to see if we've got any power. And let's have a look to see what happens. Yeah, you probably saw it flash as 5. If I hold, put this onto hold mode again. Okay, we're on hold mode again. So this will just hold at the highest voltage reading, 5.03. See how useful that is, by the way, that setting. Okay, so we've got 5 volts getting to the chip, we know that. But there's nothing coming on that other pin. Let me have a look at the data sheet again, so we find out a little bit more information on what voltage we should have here. But it's obviously like a linear regulator built into this, and at the moment we don't seem to have a voltage here, but there again this is also reading a very low resistance. Okay, let me have a look at the data sheet, one moment. Well, I've had a look at the data sheet and I was wrong, okay? I was wrong, that's not the first time, so let's have a look. I'll show you what's what. One moment. Okay, so on this data sheet, I had another look at it, and it explains in here what this actually does, this VCCC. It tells you about it in here, and this UVLO. This UVLO, this is where I was wrong. It's not an it's not a voltage regulator. It's under voltage lockout. So this detects PVCC and VCC voltage and issues. This is like a power ready signal if they're high enough, yeah. So effectively, that's what that is. And both these PVCC and VCC are both inputs, okay. VCC supplies the chip. So where's PVCC come from? Because it's not internally generated, and this is where I made a mistake. But you know, these videos, guys, this is how I do it, yeah. And I'm sure as you were doing, you know, you'll make assumptions, and then if you're doing this right, when things are not reading as you expect them to, you should revisit your assumptions, yeah. Don't say, oh, it's faulty. Revisit your assumptions, which is what I've just done. You've seen me do it, okay. And that's how you should think in this sort of work, yeah, diagnostic work. That's how you should be thinking. Okay, so we know now these are both inputs, yeah. So let's go over to the board view now and let's have a look. So this is where I've got the low resistance. This is PVCC, okay, and it goes to these two components, and it goes to here. And if we zoom out, it doesn't go anywhere else. You'd see somewhere yellow. I mean, you could say it goes to the bottom, it could be underneath, so we can flick it upside down. No, it's not. You should always do that, you know, just in case it's going somewhere on the other side of the board. It's not. So there's a capacitor here, there's a capacitor here, and there's a resistor here, okay. I'll just show you again on that, something I just didn't show you on this, okay. It has, if we scroll down here, it has a typical application circuit, which is sideways, but yeah, who cares? And it's showing us here, look, it actually shows us, I found it, yeah, PVCC comes in through a resistor, and it's from V in, and it doesn't particularly say what V in is. I mean, I could look it up, yeah, but that's what it's saying. This is where it's coming from. 5 volts is coming to VCC, and we've got 5 volts, and this should come from V in, and this is where we're not seeing any voltage, okay? So let's go back again now, and let's have a look at the board view. So there's 3 places this goes to, yeah? CP3, that's a capacitor. If I click on it, it'll tell me, oh, I've probably got a thing underneath the inset, but it's actually telling me it's a 0.1 microfarad capacitor, okay? This is also a 1 microfarad capacitor. This is I can hover over it so you can see it this way, yeah? So if you look at the thing hovering under the mouse, that's a 1 microfarad 16 volt capacitor, yeah? In fact, this 16 volt makes me think this is should be on the 12 volt rail, okay? That's a 0.1 16 volts. I mean, you can't always assume that, but it seems possible, yeah? This is a 2.2 ohm resistor, okay? And if you look at the bottom, it's saying 1-RT8889 PVCC. It's telling you where it's going to on the thing I'm hovering. And 2 is going to plus 12 volts. So this pin 2 is 12 volts. And that's where it's coming in. So we need to come back again and see, have we got 12 volts here? Yeah? We'll check the resistor also. But I'm still concerned about the low resistance I'm reading here. Well, let's go back to this resistor now and see if we actually have 12 volts on the other end of it, yeah? Okay, let's get back to the... Okay, so I've got the meter on volts, yeah? And this is the resistor that this PVCC comes in from. If I tilt the board, you can probably just see it's a 2.2 ohm resistor, which is what it said on the board here. Yeah? So we know that there's a low resistance on this end of about 6 ohms. And there's no voltage here. So what I'm interested to know now first is there any voltage getting to here on the other end of the resistor? Okay, so I'll just clip my black lead back onto the chassis, onto the ground, so I've got one hand free. Okay, so we'll get on top of here. So this is our resistor. Well, let's have a look to see when we power up if we actually have 12 volts here. So we'll just go to a volts range. What do we get? Yeah, you probably saw it for an instance. It looked like 11 point something. Again, we'll put it onto hold so we can see. 11.84 volts. So we do have 12 volts getting to there. So we got 12 volts on this end of the resistor, and we got basically nothing on the other end of the resistor here. Okay, let's go on to it. Try again, just so it doesn't hold. Yeah. Nothing getting to that end. Yeah, let's just hold it. Okay. Nothing. So that is not possible if this is a 2.2 ohm resistor, because you would have 12 volts across it. Yeah. And the current, well, if we call it 2 ohms, yeah, and 12 volts, it's like 2 ohms all in my head. Yeah, if it was a 1 ohm, it would be 12 amps. It'd be about 6 amps flowing down through here. If this end is effectively ground, as it's not far off, it's about 6 ohms to ground, so it wouldn't actually be that much, but still, there'd be a good current coming down here, 1.5 amps into 8 ohms, yeah. And if you work out the wattage, voltage times amps, there's 12 volts across this times. I mean, there's lots of watts. Yeah, this is just burn and fry. So the only really logical answer or reason to this is that this resistor is open circuit. So let's have a look. So I'll just connect my resistance, get the black lead back on. And let's measure across this supposedly 2 ohm resistor, which can't possibly be 2 ohms. And let's see what it actually is reading. And it's reading 130 ohms. Okay, so that is not a good resistor. Now, the reason it's not a good resistor might well be to do with this low resistance on this end of it, because it can't be, you know, for the wattage of this component, it can't be intended to supply a low ohms load from 12 volts. Do you understand? If you want, I'll put it on paper. I'll do it for you in a minute so you can see exactly what I'm thinking. But let's go from here now on resistance range to ground. Okay, we've done this. So it's about 6 ohms. Let's have a look on the other end of the resistor. It's quite high. So there's definitely a low resistance on this side of it, and that would explain why that resistor is open circuit. If I just put another resistor in there, it'll just go open circuit, yeah, or smoke. Okay, let me just put it on a piece of paper and let me just show you in Ohm's law what's happened. Okay, so what we've got is we've got this chip, yeah, and we've got a VCC pin and we've got a PVCC pin. Okay, and the VCC 2 ohm resistor, 2.2 ohm resistor, 2R2, make it legible, Richard, capacitor to ground, yeah, and that's your 5 volts, and we've got 5 volts here. This one is not a power to this chip, it's just monitoring this power rail, so there should be basically no current being drawn in here, and yet what we have is this. We have a resistor, 2R2, but it isn't. It's like a few hundred ohms, yeah, at least, maybe even open circuit. Yeah, we do 12 volts, yeah, and we have 12 volts there, and we have 0 volts here. And from here, according to the board view, there are 2 capacitors, and I'll check them just to be sure, but I'm sure they do both go to ground, yeah. Funny ground symbol. So, okay, so, and we have here about 6 ohms. Okay, so let's look at Ohm's law. Let's see what Ohm's law tells us. we've got 12 volts coming in through resistor, yeah, to the point of the pin, PVCC. And then from this point, effectively, we've got another resistor reading 6 ohms to ground. Yeah, that's what you can see. It could be one of these capacitors leaking. It could be this chip itself faulty, internal resistance reading too low. It's going to be one or the other, because if you look at the board view, it doesn't go to anywhere else. Yeah, it doesn't feed anywhere else. This is 2R2. So let's use Ohm's law now and work out the wattage that this would be dissipated in this circuit. Okay, so let's just do that. And Ohm's law is quite simple. So to work out the wattage that's being dissipated, first of all, we need to know the current that's flowing through here, yeah? And the current that flows through here is the same current flowing through here as is flowing through here. It's the same amount, okay? So the way we work out the current, Ohm's law, V, I, R. We put them in a triangle like this. If you remember this, you'll always be able to do Ohm's law. In the triangle, so V, voltage, equals current times resistance. V equals I times R, yeah? We want to know current, I equals V over R. And in the same way, R equals V over I, yeah? So we want to know I. So I is V over R, yeah? I equals V over R. Now, we know what V is. It's 12, yeah? It's 12, okay? And we know what the resistance is. It's the sum of these two together. 2.2 and the 6 as I'm reading, which is 8.2, yeah? For rough math, let's call it 8, yeah? Because this is it's good enough, yeah, for what we want to do. So 12 divided by 8 is 1.3, 1 1/3. Well, let's get a calculator, but it is. So here's a calculator on my phone. Since I'm going to use a calculator, let's put 8.2. Yeah, I know it was going to be what 1.33 is the answer, just over it. We'll just undo it. Okay. So the current I equals 12, which is the voltage, divided by 8.2. Okay. 1.46 amps. That's the current that would flow through this circuit. Yeah. So we now need to work out the wattage, yeah? And watts equals V times I, voltage times current. We know what the voltage is, 12, yeah? So it's 12, yeah? That's the voltage across the circuit. And the current is 1.46 amps, yeah? So the wattage is about 18. In total, 18 watts. I mean, that's enough to light a light bulb, yeah? like the stoplight on your car, okay? If it's a normal filament one. So there's no way this can be dissipated in that. We can also even work out what's being dissipated by each of these. And I can even roughly do it in my head. This resistance is about 3 times as much as this one, yeah? Like 3 2s are 6, yeah? So this will dissipate. For every 3 watts this will dissipate 1, yeah? So this is like 75% of it, and this is 25% of it. So we had what, 18 watts to start with, yeah? 18 watts to start with. So a quarter of 18 is, well, it's like 4.5, isn't it? 4.5. So that would be dissipating 4.5 watts, and the rest of it would be dissipated here, either the chip itself or whatever has got a problem, yeah? So that's why this resistor has gone open circuit, because it can't dissipate 4.5 watts. Can't do it, yeah? I was surprised it didn't smoke. It probably just went pop, yeah? So how are we going to see if we can fix it? Well, the key to this is what is causing the low resistance. Okay. We need to take the resistor out. We know the resistor's gone open circuit, so we'll take that out. And then we need to take these capacitors off to see if either of the capacitors are short circuits. If we take those two out and we've still got a low resistance, it's the chip, yeah, because there's nothing else attached here, unless there's like some sort of shorted traction on, something on the board, shorted to another point, some corrosion or something. But anyway, let's get rid of the resistor. Then let's take the 2 capacitors off afterwards, and let's see what we've got. Okay, just before we move the components, I was just checking on the actual board view again. So there we go. So this is our resistor that's got the 12 volts on this end and nothing here, and these are the two capacitors, and this end of this capacitor goes to ground, yeah, that's showing you on the drop down, ground, yeah, pin 2, and the same with this, this end goes to ground, it's connected to there in fact, yeah, so it's on ground. So either of these being short or very low resistance would cause this problem. So now I'm going to remove them one at a time, I think, and let's just see, take one off, take the one off, and let's see what happens, see if that fixes the problem. Okay, I removed the small one first, the 0.1 microfarad, which is the one mounted sideways here, okay? So we can have a look now to see if that's actually helped as a short one. So one end of these were connected to ground anyway. Well, this end is the end that isn't on ground. So let's have a look what we've got. And we now have quite a few ohms actually. What was on there? 5.72k. So we have a high resistance here now, which is what we would expect, yeah? So it would appear that that capacitor is actually short or very low resistance. I'll see if I can check them. I've got it on one side, there's a bit of paper. Let's just see if I can first of all find it. Yeah, it is. I mean, it's tiny, yeah. And let's have a look to see if we can read a short across it. So this is the capacitor. So hopefully it won't kind of go flying away. Yeah, I'll put it onto bleep mode and I'll get into the microscope and have a look so I can actually see more clearly. Let's see if we can actually manage to test this. Yeah, so this is the thing. Interestingly, it's not reading short now, but oh, yes, it is. Okay, so that's our short circuit capacitor. So as soon as I've got some, I may as well replace that. I'll put another capacitor on there. Then let's test this and see what voltage we have now and if it's actually working. Of course, I've replaced the 2R2 resistor as well that was open circuit. So this is our capacitor where we had the short of one of the two capacitors. Okay. So now we can read across here, and we have a good few kilo ohms there now. Yeah. From here to through the resistor should read 2R2, 2.4. It's close enough, so we know we've got a connection to that. I've got up to the 12 volts to find the 12 volts up here somewhere, I think. Yeah, there was one up here somewhere. Yeah, so that's through the resistor up to the 12 volts, 2.1, 2.2. So that's reading good. So I think what we'll do is now we'll power this up again and let's have a look to see what it does now. So I'm ready to power it up. I mean, there's nothing we've done that should now cause a short on the 12 volts, but we can have a quick look just to be sure. I mean, there's nothing we've done here that should be causing a problem with that, so that means okay. So we'll put the power on the power supply. Yeah. And yeah, let's just start it and see if it powers up now. There's no ramming. I mean, it might bleep. Is there a bleeper on here? Is there a speaker on here? That's a good question, yeah. Maybe it won't bleep, but let's see if it actually just stays on. Well, would you believe it came on and went back off again the same as it did before? Exactly the same as it did before. That surprises me. Let's have a look to see if we've actually got any Vcore now. So we'll get the meter onto ohms range. In fact, I'll clip the negative lead straight onto the chassis again. It's easier. So I've got a hand free to switch it on, and let's see what we've got now. So that's the meter where you can see it. There you go. Yeah, that did surprise me. I honestly expected that to actually give us Vcore now. Okay, so we're on volts range. Vcore's on the top of these low side FETs. As good a place as any. Let's see what we get. Oh, power supply on again. Power supply on. What have we got in here? No, there's still no Vcore. That's surprising me. 12 volts is coming in. Okay, let's have a look around this chip again, but I have to say, guys, that really surprised me. I expected it to power up now. So, a quick reminder then. So, this is where we should have the PVCC coming in now to this capacitor. I'm expecting this now to read 12 volts, to be quite honest. Let's have a look just what we've got. Yeah, that is there now, so we have that now. This one is where we had the power coming in the 5 volts, so we should have 5 on here. Yeah, we get 5 coming on there, yeah. And then the other one was the enable, which was down here. So yeah, it's about 1 volt or so, yeah, which should be enough. I'll check the data sheet again to see what that enable signal should be, but I mean, now it would seem we've got power, we've got enable, we've got the 12 volts, you know, that the voltage is sort of measuring to make sure it's high enough. So really this thing should be powering up, that's my opinion. But let me have a quick look at the data sheet again. Okay, so I've had another look at this data sheet, and I'll show you what I'm finding now basically. Just go over to the screen capture. Okay, so for this chip to work, yeah, it basically says here, power on ready detection. Okay, so during the startup, the chip will detect the voltage at the voltage input pins VCC, enable and PVCC. Okay, so when VCC is more than 4.45, it is because it's 5, okay, and PVCC is more than 4.4, it's 12, and actually the data sheet says the maximum could be 16. So that's 12, yeah? The chip will recognise the power state of system to be ready. POR equals high. This is an internal signal, not external, okay? And it waits for the enable command at the EN pin, yeah? So after POR, it's ready, and voltage enable equals 0.7 volts. It enters the startup sequence, okay? And at this point, it should start running. And then it goes on to say that if the voltage of any of these pins drops below the threshold, it'll stop. Okay, so that's the first thing we know, that it should start running. Yeah, and it's saying normally connecting the system voltage VTT 1.05 to the enable pin is recommended, and that's exactly what we have. So that is basically correct. Okay, the other thing, this is the schematic reflector which is on its side. Well, I've had a look around this. All these are effectively driving the MOSFETs, yeah, and the current senses. But it looks to me like this chip is not starting at all. And I'm going to prove that in a minute with the meter, yeah. So it's not starting from what I can see. These are various inputs like voltage regulator, heart, and so on, yeah. But these can't occur until the point it's running, because none of these signals can be true. And the explanations just told us basically, as long as that's there, and the enable is there, it will start up. Yeah, and we have those conditions, and they match the conditions in the data sheet. So what I'm going to do is a couple of things. I'm going to have a look on one of the phases, all of them, with the hold on the meter, and see if it actually tries to start at all, even for an instance. If it does, the meter will hold the voltage. It'll show me that. The other thing I can have a look at, and this is quite a good thing, if you have a chip that you don't think is working and it has the correct voltage coming in, a lot of chips have an internally generated voltage reference, and this one does, and that's not unusual for these sort of chips. So the voltage reference is generated internally, yeah? If the voltage reference isn't there, and assuming there's no short circuit, for instance, this capacitor, yeah, if the voltage reference is not being generated by the chip, the chances are the chip is faulty if it's got power and enable. So on our chip, voltage reference, which is on pin 11, yeah, we'll just go back up the data sheet. That will tell us about it and what it should be, what the reference voltage should be. Just scroll a bit further. Bit more, okay. Here, this is the various pins. So, voltage reference is a fixed 0.6 volt reference output voltage. Okay? It's a voltage output from the chip, and it's only used to offset the output voltage of the current monitor pin, basically. So, if this chip is good, we should have 0.6 volts on here. And the only real reasons that we wouldn't have is A, that there's like a short circuit capacitor, so it can't go to 0.6, or that the chip itself is faulty, yeah? So we can check that. So let's go back over again to our board view. So This is pin 11. I actually had a look at it. So pin 11 is here. Yeah. Voltage reference. And it goes to these 2.0 resistor and a capacitor. The capacitor, the other side, goes to ground. I'll hover the mouse over it. It's saying ground, yeah. And I'm not sure where's the end of this resistor go to. Goes to another resistor here. And where's that go to? Various resistors. It kind of wanders off this way somewhere, yeah. But I'm not too worried about it. These are lots of resistors, so there can't be a short to ground here, yeah, because it's going through resistors. The only possibility of a short to ground is going to be on this capacitor, this point here. So we can measure the resistance here, and we can also measure the reference voltage to see have we got the 0.6. We'll check for the voltage first. If we haven't got it, we'll measure the resistance. And the other thing we'll do is actually check on the output on the phases to see if it even tries to start. Okay, so let's give that a go. Go over to the microscope again. Yeah, so this is our chip. So the reference voltage is actually on this capacitor here, okay? What resistance have we got? Let's have a look. Put the meter where you can see it. There you go. So we don't have a short to ground, that's for sure. So when this chip starts up, we should see on here 0.6. Because the thing is kind of like switching on and off, let's put it on hold again. Okay. So we should see 0.6 on here at the point when it starts up. Let me just connect, yeah. I'm connected to the ground. Let's have a look. And we don't. It kind of like goes, yeah, 0.1, 0.2. So the chip isn't generating the reference voltage it should do. That's the first thing we can say. The next thing we can just do is go onto any of the phases onto the Vcore. This will do. Yeah. This is one of the low side MOSFETs. Let's see if this actually tries to start. I'll just have to switch it back onto to kind of zero the hold function, yeah? Okay, we're on hold function again. Let's see if this actually does do anything. And no, it doesn't. Well, I thought that had fixed this, to be honest. But it hasn't, so let's see if we can work it out a bit further. Otherwise, I'll order a controller chip, I think. But I mean, basically, as I've cleaned this up, I've cleaned a lot of the corrosion away from these resistors and capacitors around here. I mean, one or two of the soldering joints look a little bit iffy, maybe, a bit dried up, so it might be worth just going around and, you know, I mean, like for instance, where are we? This one here looks a little bit hard and tarnished. So I think I'd go around and just, you know, refresh, get some flux and refresh the soldering on these. But what's more of a point is there seems to be quite a bit of corrosion still under the end of this chip, this QFN. Yeah, you can see it down here probably. And I don't think I can get that out from there with, you know, just trying to clean it. I mean, I've got like a little wire brush, for instance, but it doesn't seem to be getting in there particularly well and cleaning that off. So I think what I'll do is I'll remove this chip. It's going to come off anyway if I change it. And let's see how much of that corrosion's underneath. Or maybe clean it up and put it back on. Then let's see if it actually wants to work now. Okay, so I'll get that taken off there. Let's have a look what's underneath it. Okay, so that came off quite cleanly. It doesn't look like there's any corrosion underneath here, but let's get a bit of isopropyl alcohol and just clean the area up, and let's check for sure, yeah? So just get this flux off here, give the area another go clean. Okay. Right, let's just dry bit that off there. Let's have a look, see how it looks now. Okay, yeah, that looks pretty good to me. So what I can do is now, let's have a look at the chip that I just removed, and let's see how that's looking underneath it, if there's any corrosion on the chip itself. I'll just get a tweezers and we can have a look at that. So just pick it up. Okay, so this is the actual chip, and again that looks quite clean. So what I'll do is I'll add some leaded solder onto the pads on the board, and we'll just stick it back on again. If it still doesn't work, I can order some more of these, that's not a problem. Okay, and once I've got that on there, I'll then go around with the leaded solder and just make sure that all the joints on these other components are good. But I'll replace this first, because with the leaded solder on, this should fasten back down to here before the lead-free solder on the other components melts, basically, so it will stop things kind of like wandering around while I'm soldering it. Okay, so let's get this back on here. Right, I've been all around this area of the board then. I've replaced the chip itself, the VRM controller, and I've sort of gone all around the nearby components which looked a bit crusty. There's one I'm a little bit suspect of, which I'll show you in a minute, but I'm just going to get the flux off this first, so we can actually have a look to see how this is looking now once we've cleaned all that up. And there's one resistor that might have lost the end cap, I'm not 100% sure of it. It's the one that looked particularly crusty in the first place, to be honest. So we can test that. We can check that by using the resistance meter. Okay, so that's probably got most of the worst of the flux off there. So I'll just give it a quick dry, and we can have a look to see what we've got. Okay, so I've took the flux off it. We can have a quick look. So I've just tilted the board upwards slightly. We can just adjust the focus, get it in. So we'll just have a quick look around this QFN, because it can be a little bit tricky to solder, to be quite honest. But that looks pretty good, like it's going underneath. Yeah, we can just have a quick look around, just get the angle of the board up a little bit. Just adjust the focus and I'll have it, I'm sure. There we go. That looks pretty good, I think that's good. Yeah, even the one I thought didn't look quite perfect looks good at that angle. We can have a look over here as well. Just again, just adjust the focus slightly. I mean, these things are, in my opinion, extremely difficult to tell if they're actually properly soldered, but it looks, getting into focus, it looks pretty good to me. There, yeah, that looks good. And just this last side of it, okay, just get the focus on that one. Again, that looks good to me. And then I've been around the whole area, basically, so all that sort of corrosion's gone now. I've just resoldered the end of each of the components. The only one I'm a bit concerned about is this one. So this is a 1 ohm resistor. I'll just zoom in on it. Get into focus here somewhere. Yeah, this one in the middle of the shop now. Yeah. So this resistor looks to me like it's lost the end cap. Yeah, I'll show you what I mean. This one. I'll just get a focus on it again. Zoom in a little bit. Let's just go it. Okay. Yeah, so that to me looks like it might have lost the end cap here, or it just might be tarnished, to be honest. I've got the multimeter and I've checked it and it does read 1 ohm. Let's have a look. Let's just try and scrape all this off here. Let's see. I'll use the microscope, it's easier for me if I'm actually looking down the microscope to see what I'm doing. Yeah. No, it hasn't lost the end cap at all, it's just like tarnished. I think you can see it now, I've scraped a bit of crap off it. Okay. That little brush. Yeah, I'm sure you can see it now. The end cap's on there just fine. Okay, and it does read okay as well. I've measured across the resistor into where the track goes and it reads okay. So, yeah, let's give this a go. Let's see if it now wants to work now. We've removed all the corrosion basically. Let's see if it actually wants to power up. So the capacitor's back on now. So let's give this a go. See what it does. It's connected back up then, ready to go. I found the bleeper as well this time when to connect it. So if it does power up with no RAM, we might get some bleeps out of it. I've clipped the negative to ground off the meter so we can just get onto the end of the VRM, and let's have a look to see if this actually gives us any voltage now on there. And yeah, oh, it's getting better because it kind of came up and went down. Right, so we now have Vcore coming up, but the thing still isn't booting up. This has been so troublesome. Let's have a look to see if the VRM enablers coming and going, basically being switched on and off. Okay, so as I recall from earlier in the video, the top of this transistor here is actually the enable, and yeah, it's going on and off as we'd expect. The other thing I just noticed is that the Vcore has gone up to about 1.7, and that's too high. Yeah, let's just put hold on the meter. What's it getting up to? Let's see if I can just give it a, yeah, 1.698. So the thing's now running, but it's generating too much voltage, and that makes me suspect still that I have a problem with this. So either this chip's got a problem, it's generating too much voltage, or there's a problem in the sense circuit. So there'll be like a feedback circuit in here that effectively monitors the VRM voltage and compares it with some sort of reference, which may well be internal, because this effectively can be controlled by the CPU to set the, you know, the voltage what it should be. So then the feedback circuit will effectively monitor looking for that particular voltage, and that's how the feedback will work. So let's have a quick look to see if we can work anything out here before we condemn the chip. And let's have a look to see if maybe we can, you know, take this a little bit further. So I'll just go over to the Windows desktop again, one moment. Okay, so this is the circuit we have, and you can see we have a voltage sense pin here, pin 16, yeah. We have comp or compensation, and we have feedback here, yeah. So this feedback, this effectively is monitoring the voltage, and there's like a resistor voltage divider here. So we've got VCC sense. Now this is the actual sense of the Vcore voltage, and then the chip with this compensation pin can add more to that effect. If this goes a bit more positive, depending on these two resistors, it can add a bit more and effectively feedback whichever way the circuit works. If this adds some more, it effectively makes this drive more output here, higher or lower. I haven't really looked at the chip, but basically between compensation and between V-sense, these two voltages, which are what sets the feedback voltage. Okay, and this comp voltage, I'm sure, will come from here, these set voltages. So this is where the CPU can set a voltage. I'm guessing here is like a digital to analog converter that varies comp voltage, and that effectively varies the feedback and varies the output. I'm pretty sure that's how it works. So we can have a look here. I'll just go to the block diagram of the chip again, see if that gives a bit more information. Let's see what it has. Scroll a bit faster than that. Here we go. So we have comp, this is the compensation signal, yeah, and we have the feedback, and this effectively, I would say, sets the output voltage to this slot, yeah, that effectively sets the output voltage. Vsen is here, and this is sensing the output voltage, and this is control protection logic. So I'm guessing this is like an over voltage protection, so if that goes too high, it shuts down. Okay, that's my take on it, yeah. Compensation node for voltage regulator. This pin is error amplifier output pin. Okay. Feedback, negative input for the error amplifier. This pin is for output voltage feedback to the controller. Yeah, and then Vsen. This is this voltage sense for the voltage regulator. This is what I'm sure is the protection. Yeah. So we can have a look on comp, and we can have a look on feedback, 15 and 16. that should be the same as the output. In fact, it's saying it's connected to the terminal of the voltage regulator output. So we can look at these two, and I guess they'll be going to the same voltage. That's what this thing is designed to do. So, you know, I'm reckoning these two actually basically read the same. But let's have a look and see. So we'll go over to the board view again. So we have here, let's find it. Yeah, this is comp. And it goes to the end of this capacitor and it goes to this resistor here, okay? Just a quick referral back to the circuit, just so we can see how it's connected up. Let's go back to it, one moment, to remind ourselves. Where is it? There, okay. So, from comp, we have a 59.2, 60k resistor, basically, between comp and feedback. So, 14 to 15 should have like a 60k resistor. And then, 15, this is your voltage, 15 to 16, because that's connected to you. So 15 to 16 should have a 10k. So we can probably check these, and we can check these capacitors. Let's have a look to see if our circuit actually has the same resistors and capacitors. So I'll just go back to the board view again. So comp is here, and feedback is here. And this is where we should have the resistor. So this capacitor, yeah, I'm clicking both ends of it. This capacitor is connected between the two pins, okay? 15 and 16. It obviously goes to some of the other components as well. One end of the capacitor goes to here, yeah, and the other end of the capacitor goes to here. So these are two resistors. And I'm guessing, yeah, these resistors are in series, so this end connects to each other. So this resistor is 100 ohms, and this is 56k. So that gives us 56.1. That's what's on our circuit, which is very similar, I think, to what it actually just showed us on the diagram. Have a look. 59.2. Okay, 56.1. Maybe it's slightly different on our board. So that's 56.1. So, and this is the capacitor, which is connected between the two pins. We can see it. Okay. So the other resistor, which is this one, that must be somewhere nearby, and if we go to pin 15 we should be able to find somewhere between 15 and 14. We should be able to find that resistor 10k. Okay, let's have a look. So go back to the board again. So that's 14 and this is 15. I'm just looking for, yeah, so that's what we have. That's those two in series. So where's the 10k resistor? It's this one. Let's see where it goes. So one end goes to 15, 16, yeah, okay, so 15 to 16, that's the 10k resistor, and we can see it there. Let's just compare that with our little diagram to get, again, to be sure. So, one moment, here it is. 16 and 15 have a 10k, and it reads 10k, well, we hope it reads 10k, we'll check it, yeah. And then 14 to 15 has the two in series, giving 56.1. Okay, let's have a look what we've got on our board now. Let's go back to the board and let's have a look to see what we've got. So I know where, in fact, if I go either end of this capacitor here, that's between the two pins. So that's where I should read the 56.1. Okay, there and there. And I reckon the other one goes between two other, yeah. And across these capacitors here is where I should read the 10k. Okay, I've got it. Let's go in fact, say two capacitors, one's a resistor, yeah. 10k, 56.1. Let's go have a look at what we've got now on our board. Okay, I have the meter on resistance mode. So one of the capacitors is this one here, and this is the one that should read 56.1 according to our board view, and it reads 37.6. Okay, what's the other one reading? This one should read 10k. Just go to the end of there. 1 moment. I'm doing it using the screen. So yeah, 9.46. That's very close. And the resistor here is reading quite a lot lower than you'd expect. It should be, there should be 100 ohms. Yeah, 99.7, that's very close. And this should be a 56k resistor, and it's reading 37. Now, it's not common for resistors to fail by going low value, they tend to fail by going high value. So I wonder if this is wrong, I mean, if something wrong in the feedback circuit, you'd expect this might give the wrong output voltage. Yeah, there's something wrong there. So I think we can remove this capacitor in case it's leaky, because this capacitor is connected in, effectively in parallel with these two resistors in series. If that has got some sort of leakage, then that would effectively explain what the problem is. If that isn't the case, then let's remove that. Yeah, see, there's a 37. So effectively that's like measuring from here to here. Yeah, it's the same point. Yeah, 37. So let's remove that, and if it's still reading 37, let's remove this one. If it reads 56k out of circuit, fine. If not, we'll put a 56k in there, okay? Right, the other thing I just want to do is to check one other thing on this. So let me just go back over to the board view again. Okay, so in this chip, somewhere there was a voltage reference. We looked at it earlier on pin 11. And this should be 0.6 of a volt, and it wasn't before. So let's also have a look to see if that's got 0.6 of a volt on. Yeah, let's have a look at that. I'll just go over to the desktop again, one moment. Okay, microscope. I'll find it in a minute. Microscope, okay. So, yeah, that internal voltage reference was on this capacitor here. I think it was on the top end of here. We looked at it earlier. I could refer back to the earlier part of the video. But let's have a quick look. So we'll go, just get a ground on the board. Okay, so connected the crocodile correctly to the meter again. Go to volts. So this wasn't working before. As I said, that was a very common indication that the chip wasn't working. So we'll get onto here. We'll put some power on. And let's see if this now has a 0.6 on. No, we haven't got a good contact. One moment, let me just make sure I get a good contact on it. Okay, yeah, I've got a good contact on it now, and I think, I mean, without even putting hold on the meter, I think you see it's going to 0.6, yeah? That's going to 0.6. Okay, so it's possible we've got a problem in the feedback circuit with these resistances reading wrong. So let's effectively do what I said, remove the capacitor, check the resistors and see what we've got. Okay, so I've removed the capacitor. So let's have a look to see what resistance we have across here now. And it's still 37k, yeah? So effectively this resistor will still be reading what it was reading before. So let's remove that resistor and let's see if it is actually reading 56k out of circuit. Okay, so I've got the resistor off. You can just see it down here under the microscope, tiny little thing, yeah. There. So you can see the meter. So let's have a look to see what resistance this thing actually reads, yeah. So a bit of contact on it, on the other end. And it reads 56k. So effectively whatever I'm reading in circuit has been affected by the chip basically. So I'll just check the resistance actually. Now I've removed that resistor. Let's have a look to see what you actually see on the board itself out of interest. But I think we can say that the next thing on this, we're going to have to change this chip to see whether or not that's the cause of the problem. So let's just, but let's have a quick look. Can you answer that? Okay, sorry, somebody on the phone there. It's Bjorn, a friend of mine. So, okay, let's have a quick look. So let's go onto this board. Yeah, and we cannot read the resistance there, which I can only assume is internal on the chip. So what I have to do is have a look to see if we can get some of these, change this next, because all the feedback circuit looks okay, yet it's generating too much voltage. Okay, so let's go on the internet. Let's have a look to see if we can do that, so we can get one. So here we go. AliExpress. H81M-VG4. Can we get some of these things? I can actually. Let's 1 for 797, 5 for 70. It's a little bit more expensive than some things. 1 for 5. What does it say? 5, is this the right check? 88898. Oh, you're saying 1174. That's only changed, isn't it, with free shipping for 5. Yeah, okay. So we need to prove if this thing is actually going to work, where the problem is. So I'll order some of these. I will actually get, that's including VAT. So I get 20% off that. If I put it into my basket, it's going to come up at about, well, €9 or €8. Let's have a look. Let's see what it actually does show up at 1 moment. Yeah, so I just put my personal details in so we can go back to the thing now. So, yeah, so these are saying 1174, but you can see I actually get €2 off that, so it's $9.71 because I'm actually not in the, well, I am in the EU, but I'm not in the customs unit, so I don't pay the VAT. So 24th of January, it's reckoning when these are going to get here, so I'll order those, and then that should be here towards the end of January. 1 moment, should do it, yeah, okay, ordered, as you can see. So they're on the way, and then we can have another look at this one after that. Okay.